Now let us do other example of t-test. The test we did, the two-tail test. Now let us see another example. It is given that for a building specification, the strength of the sewage pipe will be 2,500 kilogram per feet for length. So this is the given for specification of pipe. So to test this, whether the pipe make the specification or not, to test this, a sample is taken, 18 sewer pipe is taken and got the average strength is 2,550 kilograms per foot with standard deviation 120 kilogram per foot. See, here our sample size is less than 30 and in population variance is not given, it is calculated from the sample. So we want to test at 5% level of significance whether the pipe meet the specification or not. So here, see here, first of all, you have to decide it is t-test because sample size less than 30 and standard deviation not given in the population. It is given in the sample. It is given in the sample size. So you have to t-test, and which test, one or two tails. See here you have to claim is more than, so it will be one tail test. So how can you formulate test? First of all, you have to say that it is not more than, it is less than, or you can say equal. Okay, both are right. You can say equal 2,050, 2,500, or you can say less than equal 2,500. So if you write the both are right. So first of all, we in the step 1 of the hypothesis test, you have to formulate null hypothesis, alternate hypothesis. Null hypothesis, that is it is equal 2,500. That is the strength of the pipe is 2,500, and that is the pipe does not meet the specification. And alternate hypothesis will be more than, that is the pipe meets the specification. This is the null hypothesis and alternate hypothesis. Second one, we have to find out the level of significance. It is given 5% level of significance, which is 0.05. So second step is finished. What is third step? Third step is we have to find the statistics, test statistics. So as we told, the sample size less than 30, which is 18, and standard deviation is not given. So it will be t-test, and it is one sample, only one sample. And this is the formula, we know it already. So now put all the value in the formula where x bar is 2,550, which we got from the sample, and mu is the population mean. From the population is given 2,500 and standard deviation 120 and sample size is 18. If you put all the value, you will get the value of t 1.77. For one tail test, so don't need to take the absolute, we have to put it as it is. So now we have to calculate the value of, we have to find the value of tabulated value of t from the table, and we have to consider degrees of freedom, which is 70. Now remember that our level of significance for one tail is 0.05. Okay. Now let us use the table. As I told you, if you go to the table for, let us see at the end of the slide, I put the table for you. If you go there, see, first of all, you have to see first row, one tail or two tails. So our is one tail because alternate hypothesis is greater than. So what is the level of significance? 0.05. Okay, we stop here, 0.05. Column number 1, 2, 3, 1, 2, 3, 4, fifth column. Okay, 0.5. And first column degrees of freedom is 17 because 18 sample on n-1, 17. So if you go there, 70 degrees of freedom, that row, you have to stop here. Where is level of significance? 0.05 for one tail. So it is 1.740. So our tabulated value is 1.740. So now let us make the conclusion. What can we make? So we got the tabulated value is, so let us see. So we got the tabulated value is 1.740. So what is the critical region? Critical region always greater than the tabulated value. So our critical region will be greater than 1.7. Now what decision can we make? Step 5. Since our value, calculated value 1.77, which is greater than our tabulated value, that is falls in the critical region. When the value falls in the critical region, 1.77 greater than 1.70, that is it falls in the critical region. When the value, calculated value falls in the critical region, we do not accept the null hypothesis. We accept the alternate hypothesis. That is, we are not going to accept, that is, the pipe does not meet the specification, that is, which is equal to 2,500 or less than equal to 2,500. We are going to accept the alternative hypothesis, which is greater than, that is the pipe meets the specification. This is the way you can do by conventional method of critical region. Now let us test how can you do it by p-value. So we did for the p-value for two-tailed test by multiply 2. For one-tailed test, how can you get? So remember our alternate hypothesis is greater than 2500. So our p-value will be probability, that is t greater than 1.77. If it is already less than, a p-value will be probability less than 1.77. And two-tail also we call the probability t greater than, and we multiply 2. For the one-tail test, for the right-tail test also we have to find the value of probability, p-value, probability t greater than 1.77, and we have to consider degrees of freedom, which is 18 minus 1, 70 degrees of freedom. Now we know probability greater than 1.77. How can we make it less than 1 minus probability 1.77? Now if you go to the Excel, we know how can we get the Excel, how to use the Excel for the 1.77 degrees of freedom 70. Let us see, go to the Excel. If you go to the Excel, see for this p-value, again for the p-value, if you go equal t distribution, t, okay, t dist, calculate t dist, our calculated value is 1.77 and degrees of freedom 17. And second condition, we have to give the comma and we have to true, because we have taken the our value is less than equal 1.70. First we have to choose the first one, okay, then give it, we'll get it. That is the for the probability t less than 1.77 for 70 degrees of freedom 0.09526117. So let us see. So we got it same like this, okay, 0.952617. 1 minus, you will get it 0.047329, which is less than 0.5. So in the Excel we can get the p-value in this way. If we use the R programming, so R programming also I need to 1 minus pt, the value of t as it is, we give it, no need to take absolute value. Degrees of freedom we take it, so we'll get it same value 1.047. Let us test in the R programming, okay, I have R programming, we can test it. So let us test in the R programming. So first one you get it, second one 1 minus pt, okay, pt probability of t distribution, and the value is 1.77 test statistics, and degrees of freedom 17, okay, 17, get it, you'll get it, see 0.0473. the same like the Excel, we got the value. Now if you go our slide, so for R programming or Excel, we get the tabular value of p-value is 0.047, which is less than 0.5. So step 5, we have to make the decision. Step 4, we get the p-value, and step 5, we have to make the decision. So we know if p-value less than 0.05, we have to reject the null hypothesis, accept the alternate hypothesis. Our p-value 0.047, which is almost 5, but still it is less than 0.5. As it is less than 0.5, we are going to reject the null hypothesis, accept the alternate hypothesis. Same like the conventional method, we reject the null hypothesis, accept the alternate hypothesis. This is the pipe meets the specification. So this is the way we can make the calculation by conventional method and by the p-value. So please try to remember the p-value method is less than 0.5. We have to reject the null hypothesis at 5% level of significance. P-value is more convenient and easy to use. Okay, this is the way you can do in the Excel or in the R. You can do in the Python, Stata, or other program as well. So this is the way to find the p-value and make the conclusion for the one-tail test. If it is less than, just take the p-value less than 1.77, no need to do the -1. Okay, you can get directly from the Excel or from the R programming. That's all for one-tail test.